This is the video key for your turn number 1 on 8.3 lesson. So solve the system of equations algebraically using elimination, and we want to make sure to check our answer. So the first step is to make sure something is going to eliminate. Let's also make sure that this is set up nicely. So the x and the y term are both on the left side for equation number 1, and our constant term is on the right side. So that's a good setup. And then equation number 2, we can see that we've got our x and y terms on the left side as well, in that order, x then y, and it's equal to our constant term is on the right side. So these are really nicely set up for us to add the left side to the left side and the right side to the right side. Let's make sure something eliminates now. When we add the left side to the left side, x plus x will not eliminate. That becomes 2x because remember, each of them have a coefficient of 1x. Now let's look at the y terms, y plus a negative y. That will eliminate the y's because that's really a 1y and a negative 1y. And when you add a positive 1y and a negative 1y, that zeroes out. So we know that it's nicely set up to eliminate. A variable will eliminate when we add these two equations together. If that won't happen, if we look at it and we see that nothing's going to eliminate, then we need to do something else first. And we haven't quite got there yet. Right now, they're all pretty nice and will all work out, but you have to watch out for that. So let's go ahead and add those two equations together. Again, let's keep track of our equal sign by putting a line down both of the equal signs. And now we can add left side to left side, right side to right side. So combining like terms, 1x plus 1x gives us 2x. And then like we said, the 1y plus a negative 1y eliminates or zeroes out. So that's all that's on the left side is the 2x equals, and then negative 1 plus 7 is positive 6. Now we have an equation we can easily solve for, and it only has one variable. So to finish solving for x, we need to get rid of the 2. Since that's multiplication, we're going to divide. So divide each side by 2. 2x divided by 2 is x, equals 6 divided by 2 is 3. So we know that x is equal to 3. So that's the only difference between solving using elimination and substitution is that first step. Now the rest you've done many times before. So let's choose one of the equations to solve for the second variable. I will choose equation number 1. So I'm going to use equation number 1. So x, instead of x, we write 3, and then plus y is equal to negative 1. So we want to solve for y, so to get this y by itself, we need to get rid of the 3. So subtract 3 from both sides, and that zeroes out that 3 on the left side, leaving us with just y on the left side, equals negative 1 minus 3 is negative 4. So y is equal to negative 4. Now that we've solved for both of the variables, our final step is to check our answer. We have to make sure we check into the correct equation. Since we used equation 1 to solve for the second variable, I already know that when x is 3, y is negative 4 for equation number 1. So I need to check to make sure that it works in equation 2 as well, when x is 3 and y is negative 4. So equation 2 reads x, which we're going to replace with 3, minus our y, which is a negative 4. So you have to be careful here. We have minus a negative 4. And is that really equal to 7? So remember, this is just our equation, x minus y equals 7. So we substituted in 3 for x and negative 4 for y. We kept our subtraction sign. Don't combine them. It's not one big subtraction sign. It's minus a negative. And then equals 7. So since this is minus a negative 4, we know that that's the same thing as adding a positive 4. So subtracting a negative is the same thing as adding a positive. So this minus minus becomes adding a positive. So 3 plus 4, is that really equal to 7? And yes, we know that 3 plus 4 is 7. So we confirm our answer is correct. As always, we write our final answer as a coordinate point, so 3, negative 4. You have to use the parentheses to indicate it's a coordinate point. And then we also have the option of writing it in solution sets, which is using those curly braces. And that's your final answer. Thanks for watching.